For Unit 5, we'll be talking about ratios, and in our first lesson, we'll just be introducing ourselves to the idea of a ratio. So what a ratio is a comparison of two numbers. And there are three ways to write them. So I'm just going to choose two random numbers here to compare. So if my ratio is 4 to 9, then I would write it like this, 4 to 9. With symbols, we could say 4 to 9. So the symbol is like a colon, 2 dots. And our favorite one is a fraction, 4 over 9. These all work as ratios, but the fraction is the best option. The reason for that is because we know how to do all kinds of math with fractions. I don't really know so much about these other two. I don't really know if there's ways to do math with those. But for fractions, we absolutely have a whole set of techniques and things that we know how to do. All right, so let's practice writing some ratios. And I'm going to write them in different styles just to practice, okay? So teeth to no teeth. So I'm just going to count up the ones that have teeth. I got 9. And I'm going to compare it to the ones with no teeth. 15. So 9 to 15. Okay, and then I can compare smiles to the total. So ones with smiles. I got 4 that look like they're smiling. And the total, easy way to count that, it's 3 by 1, 2, 3, 4, 5, 6, 7, 8. So the total is 24. Okay? All right, how about tongue to total? So ones with their tongue out. We've got, let's see, 1, 2, 3, 4. And then again, the total was 24. Okay, angry to smiles. So that's going to be, let's see. I would say the ones with the eyebrows are the ones that look angry. So I'm going to say 10. And then we already counted smiles. That was 4, so I'm just going to copy it from earlier. Okay, now big eyes compared to teeth. So big eyes, let's see, that would be the ones where the eyes look like circles. So I'm going to do 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. So we got 12. I'm going to write them as fractions this time. And then the number of teeth was 9 from right here. Smiles to tongue. Well, we had smiles as 4. Tongue was also 4. So writing it as a fraction, this makes me think of the number 1. We're not going to do that right now, but writing it as a fraction is very useful in terms of simplifying. Silly face to angry face. Okay, well, this one we didn't count yet, so let me erase this. Let's see, silly face. I feel like silly face is probably any of the ones with, like, the crossy eyes, right? So 12. And I'll try this, writing this in the last way. And we did have angry was 10 from earlier right here. Okay, and tiny eyes to no smile. All right, let's use a trick here. If the total is 24 and we counted the ones with big eyes and got 12, that would mean that 24 minus 12 is 12. Tiny eyes to no smile. Let's try another trick there. If the number of smiles is 4 and there's 24 total, then we have 20 left over that are not smiling. All right. The order in which you write the ratio is important to the meaning. So if you switch the order around, that completely changes the meaning. So for example, teeth to no teeth, that's 9 to 15. versus no teeth to teeth, they switch around. It might be more obvious if I write these as fractions. Watch what happens. So 9 over 15, but over here now it's 15 over 9. Those are totally different fractions. We know that. Okay? Let's take a look at this next example. In the lunchroom, there were 100 chocolate milk cartons at lunch. When lunch was over, 88 had been purchased. What is the ratio of the number of cartons purchased to the total number of cartons? Well, we know that the ones that had been purchased were 88. And we know that there used to be 100, so 88 to 100. Another way to write this would be 88 over 100. Okay, next one. What is the ratio of the number of milk cartons remaining to the number of milk cartons purchased? Now, I know the number that was purchased was 88. We have to do a little bit of math here to find how many are remaining. So if you had 100 and you purchased 88 or sold 88, what's left over is going to be 12. So the remaining is 12. Another way to write it, 12 over 88. And when you look at these as fractions, you're definitely starting to see that they can be simplified. And that's something that we're going to actually get to more in the next lesson. For our next couple examples, we're actually going to skip over number 2. If you would like to do this on your own after you watch the video, not necessarily a bad idea. Just another way to get some practice, okay? For number 3, we're going to talk about how ratios can be simplified. Honestly, to me, I think it's most obvious when they're written as a fraction because we know to simplify fractions, but it doesn't actually matter. Any way you write a ratio, it can be simplified. So 3 to 6, this is 3 over 6, which we know. We can simplify by 3 over 3, and we get 1 over 2. 7 to 21, I'm going to again write it as a fraction. I know 7 goes into both, so I can divide top and bottom by 7, and I get 1 over 3. For number 5, it's already a fraction. I'm going to try 9. So if I divide by 9 over 9, I got 2 over 5, and it's simplified. 6, 100 to 60. This one, I know a trick where if it ends in zeros, you can cross them out. So now it's 10 over 6. And I think those are both even, so I'm going to divide by 2 over 2. And I get 5/3. Final answer. Okay, 5 over 25. We can try 5. It's going to be 1/5. Simplified, meaning 1 to 5. 33 to 21. Write it as a fraction. Let's try 3. So I'm going to get 11 over 7. 11 to 7 is my ratio. 4 to 13. That one's actually already simplified. And then 20 to 65. We can try 5. So we get 4. And then if you're not sure, you can check like this. Goes in 5 times, subtract. We get 1, bring down the 5, we get 15. 3 times, so it's going to be 13. So 4 to 13. Now, if you're wondering, how did I know how to simplify these? Well, basically that's just going back to factoring and our math facts. So you're going to want to maybe pull up a times table if you're having a hard time with this part of it. But as long as you understand that the order of a ratio matters and that they can and should be simplified, then you're off to a great start.